Hello everybody, I'm Lizzie and I work at the Lapworth Museum of Geology, which is at the University of Birmingham. And today, as part of the virtual Festival of Geology, I'm going to be talking to you all about the incredible Ichthyosaur. Now, you might already know some incredible facts about ichthyosaurs. You might have heard of them, you might not know anything at all. But by the end of this short talk, I hope that you will be able to explain what an ichthyosaur is. Hopefully you'll know when they were alive, what they ate, and where they lived as well. Now we're going to think about two fossils which we have in the museum, and they are these two fossils here. So here we've got an ichthyosaur skull. We can see that large eye socket and that long shape with the mouth full of teeth. And we also have a full ichthyosaur body down here. Same skull shape up this end, but with a spine all the way down to the tail, as well as small paddles, or sort of like the feet and the hands as well. So we're going to explore these fossils a little bit more. Straight away, you can see that we've got two different sizes of ichthyosaurs here. This one is much bigger than this one. That's because ichthyosaurs varied in sizes. They were about 2 to 4 meters long on average, but some of them were only as long as half a meter. Others were up to 15 meters in length. So that's a big variety of sizes. And we're also looking at different ages of ichthyosaur as well. This is probably an adult ichthyosaur skull, whereas we know this is only a baby. In fact, it was only a couple of days old when it died. So already our fossils have told us things about ichthyosaurs that were different sizes and that the babies would have been smaller than the adults. Now, when we look at the body fossil here, this full body from point of its mouth all the way down to the tip of its tail, we can start to see where the name ichthyosaur might have come from. So ichthyosaur actually means fish lizard. Ichthy means fish and saur means lizard. And it was given this name because when it was first discovered, the people who found it weren't sure exactly what they were looking at. This fossil was found with other fossils which were from in the oceans, and some of the bones looked a little bit like fish, but others looked like some sort of lizard, maybe even some sort of dinosaur. So it was given this name, fish lizard. Now, thinking about when our ichthyosaur was alive, they are extinct now. We don't have any ichthyosaurs on our planet alive anymore. But our ichthyosaur was alive at the same time as our dinosaurs. So this is the history of our planet from when it formed 4.5 billion years ago, all the way to modern day humans like you and I. And ichthyosaurs lived at the same time as the dinosaurs. So dinosaurs were alive during the Triassic, Jurassic, and Cretaceous periods. You see the little pictures of the dinosaurs down here. Dinosaurs were ruling on land. They were walking about on the surface of our planet. In the oceans, we had animals such as ichthyosaurs. So that helps us to work out how old some of these fossils are. About the same age as dinosaur fossils. Now, when we break down what we're finding in our ichthyosaur fossils in the museum, we can see, first of all, that we've got these very, very round bones. And each of these bones is one of the vertebrae, one of the spine bones on our ichthyosaur. Some of them are very, very small, and as we move closer to the head, they get bigger and bigger. Now, ichthyosaur vertebrae look very like fish vertebrae, fish spine bones, one of the reasons why it got its name. We can also look at these tiny little paddles, or they look like they should be fins like fish. If we see, they're made up of lots of tiny round bones from up towards the wrist part all the way down to the bottom. And again, we can see that in this larger paddle here, lots and lots of smaller bones and a large wrist bone up at the top. So again, we're starting to see that maybe it's not a fish because its paddle isn't like a fish fin. We also have this fossil here, and this fossil here is called a belemnite. Belemnites were squid-like creatures. They had this very large, hard shell, and they also had tentacles which stuck out from the base of the shell, very much like a squid did. Now, we actually know that our ichthyosaur was eating these belemnites because at the ends of their tentacles, they have these very little, very hard hooks. And our ichthyosaur had some of those little hooks inside its stomach. So we know that it had eaten at least a few of these belemnites before it died. And then we have this fossil down here. And does anyone have any guesses of what kind of fossil this is? Think about where the arrow is pointing to, about here. I'll give you another 5 seconds to see if you can shout out some ideas of what you think the fossil is. It is a fossilized poo. This is what we think ichthyosaur poos would have looked like. You can see that spiraling pattern in the poo from where it's been passed through the animal. And it's this pattern, it's this shape, which is what gave paleontologists, gave fossil detectives the idea that this wasn't just a stone. Now, the person who discovered made that connection between these spiraling stones being fossilized poos was Mary Anning, a famous fossil detective who lived in Lyme Regis. She noticed that these spiraling stones were often found near where ichthyosaur fossils were, or ichthyosaur bones were discovered. And she made that link of, it's not from inside the animal, this is something that the animal has passed through it when it's been alive. Now, fossilized poos are not soft, they're not squishy, they're not smelly anymore. These fossilized poos are now as solid as rock. They have mineralized, but we can still see the shape. And sometimes the shape of things which an animal has been eating are also preserved in the poo, which means that scientists can look at these fossilized poos, look at these coprolites is the scientific name for them, and work out what animals were eating and what the food chain was like in the past. So these coprolites, or these fossilized poos, are very useful for working out where animals were living and which animals were living near each other. So from looking at this fossilized poo, from looking at this coprolite, we know that ichthyosaurs were eating fish because there were fish scales in the poo. They were eating ammonites because there were bits of ammonite shell in the poo. They were eating belemnites because they had those little hooks, those hard hooks from the ends of the tentacles in the poo. And they were even eating smaller ichthyosaurs. So maybe the weaker ones, or maybe ichthyosaurs that had died already. We found those small bones inside ichthyosaur poos. So we now know when ichthyosaurs were alive, and we know what they were eating. And thinking about what they were eating can help us work out where they lived. If our ichthyosaur is eating fish, which live in seas, and ammonites that live in the sea, and belemnites that live in the sea, then it probably means that our ichthyosaur lives in the sea as well. And when we have a little look at the shape of our ichthyosaur, Scientists can work with artists to create an image of what the animal looked like when it was alive. So this is an image of what we think our ichthyosaur might have looked like. What animal does this look like to you? So I think that it looks maybe like a dolphin, maybe like a shark, maybe like a swordfish, maybe a whale. All of these animals that you are naming live in the same place. They all live in the seas and oceans. They all live quite deep down. They all are also predators. All of the animals we're coming up with eat fish. They swim quickly and they catch prey. They are predators, they are hunters. And we can see that our ichthyosaur would have been a very good predator, a very good hunter. We can see it had a very large eye socket, so it probably had a large eye compared to the rest of its body, which means it was probably very good at seeing in dark or murky water, which is great if you use your eyes to catch your prey, to see where it is. Our ichthyosaur also had very sharp, pointed, thin teeth. Sharp teeth are very good for if you eat meat or fish, because it pierces into the flesh very well. So these sharp, pointy, needle-like teeth mean that our ichthyosaur was eating fish. We also have this very pointed skull. This pointed shape means that our ichthyosaur would be very streamlined. It would be able to move very quickly through the water because that pointed shape pushes the water up and down, above and below the water, making it easier for the rest of the ichthyosaur to move through the water. We also have this long tail here. We can see here in this picture, this tail would have meant that our ichthyosaur could move very quickly. If it had a powerful tail, it could move quickly. You can see that the little paddles that we mentioned, they are only small. So these probably didn't help our ichthyosaur to swim quickly, but they probably helped to direct our ichthyosaur in the way it wanted to move, a bit like the rudder on a boat. And they would have been very solid with all of these little bones making the paddle up. So it would have been very good for helping the ichthyosaur to move quickly or change direction quickly, while the tail provided all the momentum, all that power to move forwards. Now, if we have a look at our ichthyosaur, we can see the fossil here and what we think it looked like. And the way that scientists and artists have come up with this image is by looking at modern day animals and their bones. So here we've got our ichthyosaur of what we think it looked like, and we have our fossil, but we know this is what the fossil looked like. And here we have two modern day animals. We've got dolphins and we've got swordfish. And when we look at dolphin and swordfish skeletons, we can see some similarities to our ichthyosaur. For example, we've got a very large eye. Now we can see that large eye socket in our swordfish here. Both have got that pointed shape to it. Our dolphin's got that pointed shape and those tiny needle-like teeth as well. Our dolphin's body shape is very similar. There's large vertebrae that go all the way to the tail, as well as the ribs partially up the body, just like our ichthyosaur ribs here. And so by looking at the shapes of these skeletons and looking at these similarities, we know that our ichthyosaur would have looked a little like a mix between a dolphin and a swordfish. But none of these animals are actually related to each other. Swordfish are fish, dolphins are mammals, and ichthyosaurs are actually reptiles. So if they're not related to each other, how have they ended up having similar shapes and similar body plans? Well, it's what we call convergent evolution. All of these animals are living in a similar place in the oceans. They're eating similar foods. And so through natural selection and evolution, these body plans have become very similar. So they're not related to one another, but they have very, very similar shapes. So whenever people are looking at fossils and are trying to work out what animals might have looked like, they try to find similar animals with similar shapes that are alive today. It might not tell us exactly what kind of animal the fossil is, but it will definitely help us to work out where the animal was living and what it might have been eating. They all have similar body shapes and and teeth as well. So hopefully after this talk, you now know what an ichthyosaur is, a marine reptile that lived during the Triassic, Jurassic and Cretaceous period. They were eating marine creatures such as fish, ammonites, belemnites, and even each other. And they lived in oceans where they could get plenty of animals to hunt, plenty to eat as well. So thank you so much for exploring incredible ichthyosaurs with me. I've really enjoyed being able to talk to you about these amazing animals, and I hope you enjoy the rest of the virtual Festival of Geology.